Hi, welcome back to Math's Playground. Today we'll be exploring the difference between permutations and combinations. One of the most important things for permutations and combinations are factorials. So if you wanted to write, let's say n is any number. If you wanted to write n factorial, you would write n. You would write n and then the least thing you'd expect, an exclamation point. So this is how you would write n factorial. But n factorial is equal to n times n minus 1 times n minus 2 times, you keep going on until you get to times 1. So if you wanted to find 1 factorial, that would just be 1. 2 factorial would be 2 times 1, which is equal to 2. 3 factorial would be 3 times 2 times 1, which is equal to 6. So on, and 4 factorial would be 24. So you have all of these factorials. Now that we know what factorials are, we can go on to permutations and combinations. Let's say you had 3 pencils, pencil A, pencil B, and pencil C. And if you wanted to pick all 3 of these pencils out of a box, in permutations, picking pencil A first and then picking pencil B and then picking pencil C would not be the same as picking pencil C first and then B and lastly A. So in permutations, the order of things, the order of the objects that you're arranging does matter. But here in combinations, picking pencil A first, then pencil B, and then lastly pencil C would be the same as picking pencil C first, and then B and A. In combinations, you find how many groups you can make, not how many ways you can order the objects, how many groups you can make with the objects that you have. So there are some formulas for permutations and combinations, but we won't be going into any of that for now. We'll just be dealing with equations, no memorizing stuff. We'll stay simple. Now that we've cleared our factorials and what permutation is and what combination is and the difference, we can move on to some example problems for permutations. So our first problem is how many 3-digit passwords are possible where each digit is a number from 0 to 9. So first, let's write down all the digits we have as an option. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So for the first digit, we have 10 options. And for every one of those 10 options, we have 9 options for the second one. And for every one of the 9 options for the second digit, we have 8 options. Sorry. Since the problem doesn't say that we can't repeat a digit, we would have, for every 10 first digit, we would have 10 second digits. For every 10 second digit, we would have 10 third digits. So we would be left with 1,000 options. But if it did say that we can't repeat the digits, then we would have 10 times 9 times 8, which is equal to 90 times 8, which would be, let's see, 900 minus 180. And we would end up with 720. So now let's move on to our next problem for permutations. We have to find a number of ways to select a president, vice president, and secretary from a group of 7 people. So if we want to select the president first, we have 7 options for the president. And since one person is already president, and obviously we don't have a million copies of each person, we'd have 6 options for the vice president. And for the secretary, again, we would have 5 options. So now we would end up with 210 options in all. I think we're ready to move on to some trickier questions. So far, we've done simple questions, but now let's move on. We can now try with a circle. So Gauss, Pauli, Einstein, Newton, Edison, and Faraday are sitting at a circular table. Einstein, Newton, and Faraday are enemies, so they refuse to sit next to each other. With this condition, how many ways are there for the 6 physicists to sit at the table if rotations aren't counted as distinct orientations? So, we got rotate a person's place. So the easiest way would be to pick someone at the top without enemies and then permute the rest. So let's say we fixed Gauss at the top, and the enemies won't sit next to each other. So there would be only one way. The purple and blue X's are the people without enemies, and the red crosses are the ones with enemies. And there would be one way to arrange them. But this is not the only way we can arrange everyone, because they are different people. So, but this is the way you have to put them, where the enemies should go and where the people without enemies should go. So, since we've already fixed Gauss at the top, the people without enemies, so there would be 2 more people left without enemies. So we have to do 2 factorial to find the number of ways the 2 people without enemies can sit. And then we'd have to multiply that by 3 factorial, because that's the number of ways that enemies can sit. And so we would end up with 2 times 6, which is equal to 12. It's not too hard. Circles and other things, they all have something in common. Now let's move on to combinations. It's almost the same thing as permutations, but instead of ordering stuff, you have to find how many groups you can make. So our first problem is, how many ways are there to select 3 pencils out of 6 different pencils? Since we've cleared our permutations, let's try this similar to permutations. For the first pencil, we have 6 choices, and for every 6 choices for the first pencil, you have 5 choices for the second, And then for the last pencil, you have 4 choices. But that's not what we're going to do. This is how we can order it. But we have to find how many groups we can make. And since we're selecting 3 pencils, these 3 pencils can order themselves in a total of 3 factorial ways. So we're going to divide 6 times 5 times 4 by 3 factorial because that's how many ways the 3 pencils can order them. So we end up with 6 times 5 times 4 divided by 6. So we can cross these 6's out and we're left with 20. Not too hard when we don't use the confusing let's memorize this all roar formula. So we've already done one combinations problem. Let's move on to another. Anna has an apple, orange, banana, pear, and raspberry. She wants to take a fruit basket to a picnic. How many different types of fruit baskets can Anna take using the fruits she has? Notice for each fruit, we have 2 choices. Either we can take it or we can leave it. So, so we have 2 choices. And there are 5 fruits. So we would do 2 to the 5th power, which is equal to 32. Fun fact, notice that one of these fruit baskets has no fruit. But the question does not say that this fruit basket has to have at least 1 fruit. So that is also a possible choice. See you later!